Thanks again, everybody, for coming to the afternoon session. I hope everybody had a good morning session this morning. Today is going to be all about Grasshopper Player, something called Hops and Rhino.compute, which is a couple things that we've been working on at McNeel for a little bit over a year. You may have seen the write-up when you signed up for the class. But as I was trying to write this sort of paragraph or two about what we were going to cover, I started realizing, it was a little bit too verbose and a little bit too academic. Really, what we're looking at today is all of the different ways you could use a Grasshopper definition. And for me, I think it can even be boiled down a little bit shorter even than that, in that we could really boil this down into how you can use a function. And so if we think about what a function actually is, there's tons of definitions out there in terms of software development as a function, but really all that we're talking about is a self-contained module or a set of instructions that essentially takes in some data, does something to it, and returns a result, usually. And that's all we're talking about. And so if we think about a Grasshopper definition, that's exactly what we have, right? We have some inputs or some parameters. It does something, and then we usually have some sort of output. And so for me, I think the goal today is to think about all of the different ways we can think about a function or a Grasshopper definition and how we might be able to control that or use that in different ways. Because there's been some interesting developments that we've been working on at McNeel that really open up some new possibilities of sharing and collaborating on definitions remotely. And I think we'll cover some new ways, I think, that hopefully will be new to you and how we can begin to explore the uses of a function. So really, this is what I think we can boil it down to. We can use it the way we've always done it in sort of desktop mode, where you just sort of run it locally. You have inputs and outputs, and you use it locally. We can also use something called the Grasshopper Player, which is a new method which allows you to call a Grasshopper definition from the command line in Rhino. So you can essentially bundle up a Grasshopper definition into a command that can be run without opening the Grasshopper dialog at all. And so for people who are not wanting to open up a Grasshopper definition and see all of the different components and the spaghetti code, if you will, this might be a good idea to work with in terms of how can we bundle this up and share it or distribute it with other people who just want to explore the parameter values, but not necessarily open up all of the code behind it. We can also call a definition or a function by using Hops and Rhino, and that's sending data back and forth between a local server. So we'll look at that. And you can also call a definition for Hops and Rhino on a remote server. So it's local, meaning you're running a server on your own computer. Server is just going to be another computer program which is doing something. But you can also create a server, a program that's running on another computer in the cloud, and you can make a call to that computer and return a result. So that's another way, is sort of offloading some of the computational resources to a larger computer somewhere and return the results when it's finished. And then we can also compile a definition using the script compiler. So we can actually compile it into its own plugin and distribute it through Yak or the plugin manager. So we'll show a lot of the different ways. These are all of the ways we're going to cover it today of what we can do with the Grasshopper definition. And we're skipping number 4 primarily because Rhino.compute, what we're going to be working on today, is primarily configured or set up to really work only on Windows machines. So the server code really works on a Windows machine. There are 2 ways you can sort of think about it. If you're a Mac OS user, you can still use Hops on a Mac OS, where you can either make a remote call. So you could send a call using Hops on a Mac OS and make a remote call to another server that is running Windows and then return the information. Or you can set up a Python server locally on a Mac machine. But really, we're not going to be covering a lot of the Mac side today. We're really going to be focusing on Windows, but just because of the time constraints that we have during this 3-hour session. Also, I'm going to try to keep, let me get out of this for a second and see if there's a way I can, well, if anybody has any questions, feel free to post it in the chat. I'll try to keep that up and running, and maybe one of the other McNeel people can help me out if there's any questions that I'm missing. But feel free to stop me or even just unmute and stop me if you have any questions during this. But one of the questions you may be asking yourself is why? Why do we need to do all of these different things? Well, and I think you got a good question, but I think one of the things that we're going to show today are just different methods in which you can share and distribute a Grasshopper definition. Like I said, some people may be wary of opening Grasshopper, seeing this large definition that has lots of inputs, and they don't really know where to even begin. So there's lots of different ways where we can sort of package that up and compile it so that it becomes much more user-friendly for people. I think also we're going to show ways where you can simplify a definition. So, cleaning up your code a bit so that you don't have super complicated or duplications of code. You can sort of clean up some of it by using some of the methods we're going to show. In addition, Hops in general is set up to work in parallel, so you can use parallel processing as well. So you have some potential performance gains that could be used if you're using very large simulations or large calculations. Or alternatively, you can make function calls that are asynchronous. So if you have a really long simulation, which normally if you were running it on your Grasshopper definition would sort of lock up Rhino and Grasshopper. You can't really do anything because it's all single threaded. So your Grasshopper definition sort of sits there, and Rhino you can't move around until that simulation or calculation is done. For Hops, you can actually send it and call it asynchronously, so you can still move around and continue working, and then when it comes back, it will continue on throughout the definition. So I think there's a few different positive reasons why we might want to look at some of these different methods. So a little bit about me. I am a new developer at McNeel. I live in South Carolina. I have a doctoral degree from Harvard, a master's degree from Columbia, and a bachelor's degree from Clemson. I like woodworking as a hobby, and you may or may not know I have an identical twin brother, so something maybe a little different. Today, really what we're going to be covering, like I said, we're going to try to break this down into the first half, which is going to be covering sort of what is a function, how does the Grasshopper Player work. We'll look through a few demos, and then we'll take a quick break, maybe 5, 10, 15 minutes, depending on where we are time-wise. And then the second half of the workshop is going to be jumping into Hops and Rhino.compute. And then hopefully we'll have enough time to cover the script compiler and answer some questions towards the end. So that's sort of the schedule for what we're hoping to achieve today. Again, if there's any questions, let me know. I don't know if my interface is actually allowing me to see the chat, but again, I think probably the easiest way is to just simply unmute yourself and ask the question. Feel free to interrupt. There's no problem with that. Okay. So I don't know how many of you, again, this is different on a webinar series, but normally, if I was walking around the room, I could sort of look you in the face and ask you how much programming experience you may or may not have. Some people have never actually opened a code editor and written their own code, and then others of you probably have lots of experience and may even do it every day. But for the most part, if you don't have any experience, a function, like I said, is really just a block of code that takes in some information and returns some type of data. So it would look something like this. Now, again, not to scare you off, if you've never done any coding, I don't want you to get scared off and shut down the Zoom link. We're going to walk through this and sort of explain how all of this works. So really, the first thing we want to look at is we have to give a function a name, right? So this first part, the part in sort of brown or yellow, is something that we would define the name of that function. And then we also have to define what type of information are we going to return. Is it a parameter type of an integer value? Is it a double, which is a decimal value? Is it a string? There's lots of base types or even complex types that you can return as part of the function. We have inside these parentheses, we pass in a list of input values. And these, again, can be different. They can be a list, they can be individual items, but inside those parentheses are where we define the type of inputs that are going to be used inside this function. Then inside the curly brackets, you see those white curly brackets, there are a bunch of instructions. So again, this can be as long as you want, but typically you try to keep a function as concise as possible. So you have a list of instructions that the computer goes through and performs some sort of procedure. And at the end, we return a value, usually. Again, you don't always have to return a value, but typically you would return something, which just means like if you're adding two numbers, you would return the sum of those two values. So hopefully at this point, I could show you this code and you could tell me what it does, right? So we know the name is called find maximum. We're going to pass in two integer values, one called num1 and num2, and we're going to return an integer value. So you can see the return type on the far left is of type int. That just tells the computer that we're going to be returning an integer value. And then what happens in the curly brackets, we just do a check that says if number 1 is greater than number 2, then we return that one. Else, we're going to return number 2. Pretty simple. So you've now sort of understood how we can read a function and in code. Now what we're going to do is look at how we can really do the same sort of ideas, take those same sorts of ideas and apply them as a Grasshopper definition. Because again, to me, what all of the stuff we're going to be looking at today boils down to is this idea of functions, right? We have inputs and outputs. We have to define them in some way. And the way we define them using the Grasshopper Player and Hops are using these new components, these Git components that you see here that I've highlighted here under the params utility tab. So you can see there's a Boolean, a Git geometry, Git line. There's a number of different types of Git components that you can use to get those input values that you'll use as part of your function. So each of these values, and we're going to go through these in more detail. I'm just going to run through this kind of quickly. Each of these getter components, if you will, have a right-click menu that you can bring up when you right-click. And really, when we're talking about, they have different values, they have different functions. Each of these values have different functions depending on whether you're going to use this as part of a Grasshopper Player definition or a Hops definition. So we'll explain that a little bit more, but right now, the first input value you see is the name of the component. So we give it the name of the component, and if we're talking about the Grasshopper Player, what this means is that this is going to be the input parameter, and I apologize, this is talking about Hops. That should actually just say the name of the parameter value. The command line prompt is what will be displayed to the user when we call the Grasshopper Player. So for the instance, this particular parameter is going to ask the user in the Rhino command line to provide an integer value, right? And so if we were using this to define, say, the radius of a circle or something like that, the radius of a fillet, you can actually say, type in the value of the fillet. You can type in whatever you want, but that's what will be displayed to the user on the command line. We also have these other values, which are essentially the minimum and maximum number of expected values that you want the user to provide. So again, it doesn't have to just be a single value. If you want to have them provide, a list of points or a list of integer values, you can do that by setting the least. So how many numbers what's the minimum amount of numbers you need to satisfy to proceed on, and what's the most number. So if you want only 5 points to be used as part of your input, then you say at most 5, and then when it's got 5 points, it will then proceed on. Some of the components also have this minimum and maximum. Usually the number components have a minimum and maximum, which is just simply to set a minimum and maximum range for the values that are coming in. And then some components, like a string component and the integer component and the number component, also have a preset form that allows you to define a list of presets that will show up as part of the command prompt. Now, I want to bring up some of these. If you're looking at this component on your own definition, some of these have not been merged in yet to the base code because some of these features were added within the last couple weeks. And so I believe like presets, for example, are not going to be merged in until the release 7.13 release candidate. So unfortunately with 7.12, it's not available yet. If that's the latest service release you're on, we'll have to wait till 7.13, which I think is released pretty soon in the next couple weeks. And so you should be able to see some of these new features coming online. But here's what a function would look like for the Grasshopper player. So normally what we would see is we just have these, we have 2 integer get components, which are just saying these are those contextual getters, and we've labeled them num1 and num2. We have an option to provide an input to that parameter. So if you provide an input, all that's going to tell the computer when you save it and you run the Grasshopper player is that will be the default value, right? So if you're saying you want a default value for the radius of 10, you can give it a default value by passing it into the input, and then the Grasshopper player will show the default value to the user. Then we have to actually do something, right? So this can be a number of different components. This can be an entire definition, but essentially we do something with those values, and then we return the value at the end, right? Again, we don't always have to return something, but usually you might bake something into the scene, or you might use something like this component, which is a context print, which will essentially just use like a text panel to display a text panel to the user. So let's take a quick look at like a demo of what some of this might look like. So if everybody wants to join along, I'm just going to open up Grasshopper, and we'll just look at that base example, right? The first thing I wanted to highlight is we go under the utilities panel, and here you can see we have those Git components. There's also a context bake and a context print, which we'll talk about as well. But here, you can see a number of different types that you might want to use. So let's just use like the Git integer component, and we can name this, A. By right-clicking, you can set the prompt. So when I right-click and say set the prompt, this is just going to say specify the prompt message that's going to show up when we call this in the Grasshopper player. So you can say set the first number, and that's really all we need to do. At least is already set to 1, and at most is set to 1. So that means it's only expecting a single value, right? We're not passing in a list. We're just simply passing in a single value because at most is set to 1. That will be important when we start to talk about hops and how hops deals with lists versus item access and things like that. But at most the default values are set to 1, so it's sort of like an item access. And then we have a minimum and maximum, which I'll just leave blank for now. Is there a question? Nope. Okay. So I'm just going to copy paste this one and rename this B. And we'll prompt for this one to be set the second number, right? And then again, if we wanted to, we could do the maximum value, which is just sort of repeating that function, and we'll get into more complex functions here. But we can then set this into a context print component, which this, like I said, is something that will pop up to the user and explain like what it is you want to show. So in this case, what this is passing out is the maximum of A and B, and so that's going to be shown in the text panel right here. So if I save this definition, I'll save the document as, we'll just name this find max workshop. Now I can close Grasshopper altogether, right? So we didn't have to do anything other than set up the getters, we do something, and then we return something. So I close it all together, and now if I type in the Rhino command line, I start typing Grasshopper, you'll see down in the list there's a Grasshopper Player, right? So we can type in Grasshopper Player, and when we do, it asks you to open a file. So I've navigated to the workshop files. Again, hopefully all of you got the email that had a link to the Google Drive that had these workshop files. But I'll just find the one that I just created. And now you can see that it's asking for me to set the first number, right? So again, this can be any integer value. I didn't really set a minimum or maximum, but let's say 20. And then it's going to say set the second number, let's say 30. And at the end, it says the results of this are being returned as 30. So I could have done any number of operations there, right? If I go back into Grasshopper, I could have, done a concatenate where I take in the value and then I pass in a string that's like the maximum value is, and do space, and then pass this into the context print. And now when I run this, right? So all I've done is created a new thing, a new string value that I'm passing in here. I hit save and I run the Grasshopper Player again, and I'm going to use that same value, or same definition, excuse me. So it's asking me to define the first number, we'll say 20, second number is 30, and now you can see the string says the maximum value is 30. So this is really an interesting way to start thinking about providing inputs to a user, which can then, be fed into a Grasshopper definition and then do something. So let's look at a more complex example here. I'm going to—
Andy, there's a question on chat about passing a list and what happens with the minimum value.
Okay, yeah, so I didn't see, but you're saying, what if we define like a minimum, are you saying like a minimum value here? So if we set like the minimum value 5 and the maximum value of 10, and then we try to pass it a value that's outside those bounds?
Well, yeah, I think
Yeah. Go ahead, I'm listening.
Yeah, so I'm saying if you pass in a minimum value of 1 and you set a minimum value of 1 and you pass it in list, how does it handle the error? Like, does it break or does it just—
No, it won't let you. Are you saying that this at least part?
Yes.
Okay. No, it won't let you set a list, right? So it's asking, it'll say like, so if I say at most 2, so now it will say, and then hit save. So I can say Grasshopper Player, and it will basically do it twice in this instance. So I'll say find max workshop. So it says set the first number, I'll say 10. Second number, I'll say 6. And then I see it says the second number again, right? Because I said at most 2. In this case, I'll say 20. And this should pop up and says, see, the number must be smaller than or equal to 10. So that was part because I put the maximum to set to 10, right? But also it's asking me a second time because I set the at most value to 2. Hopefully that makes sense. So I'll set this to, I'll set the other one to 8. And now you can see it basically ran it twice. Just like it would if you were to pass like a list, like longest list, and it's running through. Because it's set to 2, it's going to compare the first value and then it's going to compare the second value. It did it twice and it returned the same value because my first value was the largest of both of those. Does that answer your question?
Yes, it does. Thanks.
Okay, perfect. Okay, so I'm going to look at a slightly more involved definition, and I'll see if I can move my screen around a little bit. So in the workshop files, I've opened this base file. It's called trusses base. And then there is a trusses base a component, or sorry, definition here. And if I open that up, excuse me, I'm going to get a drink of water. And where did my... There it is. Okay, so what I have here is a surface that is being created by a set of U curves and V curves. So it's just a UV surface, network surface. So I've got, I think, 3 curves in the U direction, which are these red curves. And then I've got 2 curves in the V direction. So it's going to define a sort of network surface here. Then, you know, we're just doing a little bit of math and some lists culling to essentially create a series of trusses. And you can choose to flip the surface. I'm not sure what, there we go. And I believe it's partly a little bit laggy because of the piping. So we're using the pipe command, which is still kind of a long calculation for Grasshopper. So I'm going to turn those off in a minute. But essentially, you can either decide whether you want to provide some trusses on the outside or inside of the surface. So I'm just trying to create an example that's a little bit more maybe common that you might see in your day-to-day work. In which case, you know, all we're doing here is I've defined, these are the curves. So if I actually turn these off, if I just disable these, or actually I should disable these, because those are the pipes, and turn these back on. These are the actual trusses, the truss members that we're looking at, right? So that's all the curve work that is what's being created by the rest of this definition. So you can kind of see that I've defined it so that I've got some input values. These are essentially setting, you know, the depth of the truss, the number of trusses that are being drawn, you know, created along the surface, the number of webs, so the webs in the trusses, and then at the output side, we've got the surface and the chords themselves, right? The actual curve geometry. So I wanted to look at this and see how we could turn this into a Grasshopper Player definition, right? So if we look, we've got some curves here, and it's asking, in this case, we have 3 curves in the U direction. So I'm going to go up here and say get geometry. And in this case, I want to, the geometry component is a little bit different. You can see you can specify the type of geometry you want to pass in. So in this case, I want to set the curves. Now you could go through and left click and select, you know, all the points and the surfaces, all the other ones you don't want. But a little trick should be that you can right click on that and it will invert sort of the selection process. So if you right click on one of those, you can turn all the other ones off, which sort of makes that a little bit faster. Another thing you can choose if you want or not, I'm not going to set that this time, but essentially if you wanted to take the geometry that you're using as an input and then delete it at the end of your Grasshopper Player call, you can choose to do that. So there's a little checkbox here that says, do you want to delete this input geometry after it's done? In this case, we'll just leave it as it is. So in this case, I want to set the name to be U curves. So it's sort of the same thing we're doing that we're creating here. And then we might want to set the prompt to be something that would be recognizable by the user, right? They need to know, are they selecting the green curves or the red curves? So we could say something like set the U curves of the surface. And you can even be hint, it's the red ones. Something like that, right? The other thing we need to look at is the at most, right? So we just have this question, which is what happens if we want to pass in a certain number. In this case, you could define it as 3, or you can really just define it as unset. So I can just delete it and hit commit, right? So I can, if I do that, if I look at most now, it has no value. And if it has no value, it's sort of like an unending list, which just means that it will continue to ask the user for something until it gets a value, until you right click or hit escape or enter. It will sort of wait and ask for more until you, like I said, right click. So in this case, we're going to unset that value. I'm just going to go ahead and copy this too and make this one the V curves, right? And again, we have this unset. The only thing we really need to change is the prompt to the user. So, and now this one will say is the green ones. All right, so we've got our getters, but they're not really doing anything yet. We haven't connected it. So if we wanted to, we can set the default values here by passing in these values. And then we need to just essentially look at where these components are connected and then replace those with the output of this Git component, right? So it's really just feeding this one surface component is where those were going, as well as the V curves are being used down here in this curve divide component. So I can pass that there. Now, our U and V curves, when we pass those in, when we select those by the user, those will get passed into the definition and continue on, solving. We have a get Boolean component. So here we can go to get Boolean, and I can add that. Now this is just asking, do you want to flip the surface? Or it's flipping the surface, which is then, determining which way to orient the trusses. So in this case, I'll pass this as the input. I will rename it flip. And then I'll say, as a prompt, do you want to, or I'll just say flip surface. Now, with this one, because it's a Boolean component, you can actually define what you want the true value to say in the command prompt and the false value. So you could say flip surface true or false, but it might be more user-friendly to say yes, no in this particular case, right? So I can say specify the value to use for the true state. Same thing with the false value. I can say no. So now when the user is going to say, it's going to present them with some options, it'll say flip surface and then have two options in the command line, one that says yes or no. And so now we just have to determine where that goes, and it's into this gate component, or sorry, the stream filter component. So we'll just replace that value there. Lastly, we just have these three inputs, which are the depth, and number of trusses and webs. So this first one is a number component. So here we have a number component. We'll say truss depth. We'll set the prompt, set the truss depth. We can set a minimum value so that we don't go too low, right? You might have a minimum. I think I'm in have units of feet here. So I might say, I don't want any trusses that are less than a depth of 1 foot. So we might set a minimum value just to sort of clamp that value. In this case, we're just going to set at most to 1. And we just need to determine where this particular slider is being connected to. So it looks like, if I come over here, it's going into this distance value in the curve offset. So I'll pull this back and then pull this back as well. So again, I'm just really trying to define what these numbers are. If we wanted to, I could, well, we'll just finish it out. Are there any questions while I do this really quickly? So we'll just do we'll do a get integer component for the number of trusses. Again, feel free to stop me. And we're just going to figure out, so that goes to this input. And then lastly, we will do one more get integer for the number of webs. Okay. And that's just going to go into this A component. So we've now sort of defined our inputs that we're going to present to the user, right? We have this, we've now sort of taken all of our input parameters, we've replaced them with Git parameters, and now we need to define what it is we are going to do at the end, right? So I mentioned, we showed before, with the Grasshopper Player, you can return a context print, a string value, but we also have this context bake component. And that's where we actually say, what is the stuff you want to bake at the end of your Grasshopper Player, right? So at the end, when it's all done, you can pass in some sort of geometry or points or whatever you want, and you can bake that into your scene. So in this case, I'm just going to hold Shift down and pass in all of these curves here and the surface, so that at the end of the result, it should bake this geometry on into the scene. And so we have that now defined. So we've defined essentially this function that has some inputs. We do something. We have a set of components that does something. And then we have an output. So it's very similar to what we just talked about at the beginning and looking at how a function is defined in code. We've just done it sort of in Grasshopper form, right? So I'm going to save this as trust base workshop, or I'll hit save. And now I can close this down completely. And again, I'll still need the Rhino open because I need these curves. But now I can open up the Grasshopper Player again. And I'm going to go find that one. So trust-based workshop is the one that I just saved. And when I do, you can see it gives me a preview. And that's partly because I had the preview turned on the components that were being shown. So whatever you have left on in your Grasshopper definition will still show up as a preview as you select these. But you can see it saying set the U curve of the surface. And then you can see it says hint is the red ones. So I select one, then I select the second one, and you can see it's setting it just for the curves that it's got so far. So it doesn't know about this third one yet because I've only set 2 of them so far. So it's trying to define what we have. Now I set the third one, and now it's still asking me for the U curves because you remember we didn't set a limit to the number of the list that we were going to ask for. So now I right click, and now it's switched to the next Git component. And one thing I forgot to mention is that in the Grasshopper Player, at least, the order in which it's displayed is the order on the canvas, so top to bottom. So if you want to order your parameters that are presented to the user in a specific way, you can sort of order them on the canvas top to bottom, and that's the order they'll be displayed. So now we just define the surface, and there we have 2 V curves, and so it can create the surface, and I'll right click. It's asking me, do I want to flip the surface? And here you can see those are the options that we just defined. Yes, no. You could have said true, false. I'll say no. We'll set the truss depth to 15, the number of trusses to 8, the number of webs to 8. And now you can see at the end, it baked everything that we just passed in, right? We baked in the curves and the surface. So that is how the Grasshopper Player works. Let me just open it back up. So again, it should be fairly straightforward in terms of we have these new Git components. So again, there's a new, you can ask for string values. So if we wanted to, a string is just some text. So if you wanted to pass in some sort of statement that the user provides, like a name, you can ask for a name of something. You can do a file path. So if you want to pass in a file path that then gets passed in like an image or something like that, you can do this and it will actually ask for an open file dialog. So similar to the file path component here, when I say set one existing file, it opens up a dialog box. So that's what will happen here is when it hits this get file path component, it will bring up an open file dialog to actually get you to specify a path to a something. There are, let's see, points and lines. So again, you can specify points and lines, which are also like geometry, but in this case, you can actually specify them real time. So you can, instead of passing in a curve by selection, right? You can actually set a line the same way you would with, say, the line parameter. So if we say set one line, it takes us here and asks us to define the line. So that's the same as what would happen if in the line getter, is that you can ask it to essentially define a number of points or lines. So there's a number of Git components, and if there's ever any requests for new parameter types, you can let us know. You know, we've tried to provide a good number of components that we feel would be useful or helpful to users as they begin to develop their list, but obviously some of these are fairly new. I added the Boolean and file path ones just in the last month or so. So we're always adding more, and if you have some suggestions, we're happy to take those.
Hey, Andy.
Yes.
I don't have the get file path component in my player. Is that just not merged into the code base?
My guess is that you're still on a slightly older version of Rhino. So if you go to update, if you go to your tool Rhino options, you should try to see if you're on SR 7.12.
I'm 7.11 right now. That's probably why.
Those were merged in 7.12, and then like I said, the presets. Remember how I showed you the presets on the PowerPoint slide? That's even in 7.13. So I would suggest downloading the latest service release. And actually, I think if you restart or you do check now, it will try to download that newest one. So that's
cool.
why that's not there. Is that those components, the Boolean and the file path, are just newer. And that's all that means. And same thing with the presets. Also, some other things like this doesn't show enable or disable or preview, but in the 7.13 build, those will. So you'll have the ability to turn these, the visibility on and off, or whether you want to enable or disable those. So that is something that's also available in the next release, the next service release that will be 7.13.
Cool, thanks.
Yeah, no problem. All right, I wanted to show one other interesting example. Before we sort of take a quick break, we can answer some questions, take a quick break, and then maybe get some water or whatever. And one is this twisty tower kangaroo slider thing. I'm just going to open that and show you what that looks like. Now, I didn't really document this very well. So I apologize. And for those of you who aren't familiar with Kangaroo or don't really want to get involved with Kangaroo, I totally understand. But Kangaroo is a really exciting and interesting plugin. I'm sure you've seen some videos of Daniel Piker, who's done some really amazing things with it. But what we found is that you can kind of use Kangaroo to hack the Grasshopper player in some interesting ways, or at least some people have. Some of these were actually users figured out the use of Kangaroo and then showed it on the Grasshopper forum, and we were kind of blown away that you could sort of do some of this stuff with Kangaroo and the Grasshopper player. So what this particular example is going to do, let me just open up a new. I'm going to open up a new Rhino file just so that it's not. So all we have here is a twisty tower, right? It wouldn't be an AEC workshop if we didn't do a twisty tower, right? But what we have here is sort of a real-time ability to adjust the preview with the user. So here we've got a vertical slider that allows us to control the number of floors, and a rotational slider, if you will, that allows you to control the twist, right? So let me walk through the Grasshopper definition of how this is set up. So one thing is we have one input value, get component, which is just asking for the number of sides. So right now we've got this set as a default 6. You could give it a different value, a default 5, and it's just going to change the shape of the tower, right? So that's just one simple input value you can define. But the interesting thing comes when we start to tie in Kangaroo. And again, I'm not going to get into how Kangaroo works and all that, but it's really pretty straightforward. all we're doing, this is the Kangaroo solver, and all we're doing here is one goal that we're passing in is this pick component. So there, if we, I don't even know which menu it's in, but if you actually just type in pick, I think it's pick. Sorry, grab, the grab component. All that allows you means is that you can grab some of the nodes that Kangaroo uses in the viewport. So if you pass this in, it just means that it allows you to take whatever object you're passing into here and grab it in the viewport. Then we've got these two other goals, and they're the same type of goal. All it is what's called on curve, and I think it's on. Sorry. Goals on curve. So if you hover over it, it says keep a point on a given curve, right? So all it's asking for is what is the curve and what is the point. So in this case, this line, if I hover over it, is that vertical line, right? That's the line that we're trying to keep the point on. And then I've just got a midpoint component, which is just specifying the midpoint of our line, right? So I've got this component's job is just to find the midpoint of that line. So I pass those in and I set the strength to be a little bit high, like 100, but I don't know if you even need to do that. At the output, it's going to give us the actual point, right? The one that you grabbed, that you're moving. So again, this Kangaroo goal, its job is to simply keep the point on that curve. So if I try to take it over here and I move, my mouse way over to the left, it's not going to let that point get too far away from the curve, right? Again, that Kangaroo goal's job is to try to keep it on that curve. So then we have our point, and now all we have to really do is figure out where the position of that point is on that curve, right? And then we can, once we know the position on that curve, we can sort of do, is it 3/4 of the way up the curve? Is it 90% up the curve? Is it 10% up the curve, right? And we do that by using this closest curve, this curve CP component, which is just gonna pull the point to the curve. So, or find the point that's closest on the curve. And the neat thing about that is it gives you the t value. In this case, it's the parameter value along that curve. So again, you can think of that as a percentage along the curve that the point is on. So is it 10%? Is it 90%? It's going to give us 0.9, right? So then you can just remap that value to the total number of floors, and now you use the rest of this is however you generate the number of floors, right? This value gets fed up here and creates the curves and then makes the floors, right? So that's all that's doing in terms of creating, and let me just turn some of this stuff back off, is creating some of those values. The same thing is happening for the circle. So here, if I turn on the circle, sorry, it's this circle. Here is that circle down below. So you've got a circle, you've got a point on the curve, and then you're trying to keep that point on the curve, and then you're essentially figuring out where on that curve that point is and using that as a value to twist the tower. The one thing I might bring up is that you also usually need at least one input parameter, or usually one extra input parameter when you're running a Kangaroo simulation. The reason being is, you remember with Grasshopper Player, it immediately, when it's solved all of its inputs, it's done, right? It's done its job. Like we asked for the trusses, the number of trusses, flip the surface and all of that, and it was finished. And when it finished, it baked everything. Well, we need it to stay sort of live or open for Kangaroo to continue doing its job, right? So Kangaroo is sort of running in the background. And so we do that, and you can do it really any way you want. You could do an integer value, which is just saying, press any key to end this example. Or you could have a Boolean where you say like in solution and yes, no. But you need some way to ask the user to when it's done, okay? So in this case, I'm gonna close this example and then show you, and close this, and then show what it looks like when we call that in the Grasshopper Player. So here we call it the Grasshopper Player. We're going to navigate to the workshop files and pull up the Kangaroo Slider. So here you could pass this to a client or a one of your designers on your team who has the ability to then not open your definition in any way, but has the value, who can then decide whether they want a four-sided tower. You could set parameters. Right now it's actually tapering, so you could actually set parameters to taper it. You could, you guys can think of any number of ways to enhance this, but then we can control the number of floors in real time. We can control the twist as well. And so we're twisting the number of, we can control the twist. And then when we're done, you see it's asking for in the solution. And it doesn't really matter if we say no. So Boolean might not be the best way. It might be a string input, which is just say, hit any key to end the solution. So, because if you hit no, it's still getting a value and then going to end the thing. So I'm going to hit yes. And then now you can see we've actually baked in our geometry, because that was also part of this. That surface and the floors were passed into the bake parameter. So now we can actually bake that geometry in and be done. So I think there's some there's a thread on discourse, on the Grasshopper discourse page, which actually shows people who have taken this idea of kind of creating their own widgets, if you will, their own sort of heads-up display widgets that allow you to control a definition in real time, which I think is a really powerful tool. And I've been really impressed with what people have come up with. So I would encourage you to, if you're interested in it, just try to explore or look into the discourse forum a little more about ways you might be able to take this and enhance it. So first, are there any questions so far about the Grasshopper Player, about the Git components, or anything we've shown?
Is it possible to go back and correct the input? Like, it was kind of pretty linear. Like, so you input and then you move to another parameter, and then you have to, complete the solution. But would it be possible to go back?
It depends on the input. And it also depends if you have, usually it's if you, let's see, if it is set to a list, it will allow you to, like on this one, if I go here and try to pull up that first example that we did, let's see, find maximum workshop. So I set the first number, and then the second, and so then the second one allows you to undo. So you can go back to and set it. So there are ways to actually choose an undo. I don't know, it may be a little bit buggy because I was just looking at that example with the twisty tower. Let's try that one and see if it allows us to undo the side number. I don't think it does. So there could be a bug in our code that we just haven't worked out yet. But so we could set it to be an 8-sided tower. And yeah, see, this doesn't allow me to hit undo. So I think we do, it is supposed to allow you to do an undo. And so, but I found that maybe we haven't worked out every solution. So I probably need to take a little bit better look at that in the code. So thanks for bringing that up. But the answer is maybe.
It'd be really great to, it's, how in Rhino, when you have, when you use the command prompt in Rhino, there's all these parameters that are underscore, and then you can click on them to set those parameters. It'd be really great to have that here too, so it feels more seamless with the rest of Rhino.
Say that one more time.
You know how in Rhino, when you say like, when you type in a command and then all the parameters are there for you to set, and then you can sort of pick any one of the parameters. Some of them are sort of optional parameters, so you can like either change them or not change them.
So that's
awesome.
Exactly what the presets does. It's only in some of the components, because obviously some it doesn't make sense. So for strings and integers and numbers, you can, and again, this will be available in 7.13. That's the only reason I didn't show it. Is I wanted to be using the same version that you guys were on. But essentially, if you click this, it will bring up a modal that allows you to create a list of preset values. So it could be 45, 90, 180 for your twisty tower. And then when you run the definition, those will show up as options.
Cool.
And the person can just click on the option instead of typing it. They can do either, right? They can still enter it in. It's still a numeric input or a string input, but there are ways that allow you to set preset values that show up as options, as predefined lists.
Cool.
What other questions are there?
I think
Hey, oh, sorry, I was just going to ask real quick. To run that last example with the tower, would the person who specifies that script need to have Kangaroo downloaded?
Yes, but Kangaroo comes with Rhino now. I'm almost positive. That part shouldn't be a problem. But yes, you can run because essentially it's just running it in the background. It's essentially running Grasshopper in the background. So whatever component you're using now, if we type in the package manager and it's installed and your whatever plugin is used is on the package manager. So let's say you distribute that file to a user and they don't have that plugin, but it's on the package manager, a window should pop up and say, you're missing this plugin, do you want to try to download it? And then it will go and download it for you. You may have to restart Rhino, but once you do that, it should go ahead and do it. So depending on the plugin you're using and whether they've been distributed on the package manager, you should be able to hopefully navigate that issue. It can run whatever plugins you have on your machine, but the other user, if you distribute it to it, would have to have those same plugins. Does that make sense?
Thank you. Yeah, that makes sense.
Good questions. Anybody else?
Hey, one question, Andy. Sorry if I missed this, but are the Git components able to take a tree input, or is it only a flat list? And is there a way to validate that? That's the second part.
For the Grasshopper player, no, it's a list because it's just really going to ask the user, one after the other, what you want. For when we get to hops, yes, you can pass it in a tree. We'll explain how hops works because hops uses the same components here to create input parameters. And so you can pass in a tree, and depending on how you define whether you're doing at most or as one or unset, will determine how it makes calls to the remote server.
Got it. Okay.
So the answer again is sort of maybe. It's a list when you're running the Grasshopper Player. It can be a list or a tree in hops or an item.
Sure, sounds good. Thanks.
Okay. Anybody else? All right, why don't we take a, what do we say? Till it's 3:02 my time, so why don't we take like an 8-minute break? I'll stay online and can answer questions that may have popped up. But why don't we take a break? Anybody can use the restroom or anything, and we'll meet back here at 3:10 local time. I will see if I can figure out the chat.
As I was asking the question, I just realized, Andy, that a possible workaround for the tree could just be comma separated string input, which then is decomposed on the player side, right? Like nothing stopping us from inputting a string with brackets.
Correct.
Right?
You can have that as in whatever you want as a string. So yeah, that would be a okay workaround as well.
Yeah.
Kind of convoluted, and maybe we need to think about that as an option, whether we
like some sort of preset delimiter of like square brackets are your branch level, commas are your items or whatever.
I don't think we would want to set it to the user, but if we set at most to be more than one, maybe there's something that says like, if it's more than one, do you want to treat this as a tree? In which case, do you want to graft it or do you want to flatten it? You know, I think it's also a question of like, how do you want to treat it as a tree, right?
Right. Oh no, but wait, if you set the
as a list, and then once you have a list, do something with it after, you know, when it comes in, it's a list, and then you graft it or, you know, do some other sort of operation.
Yeah, well, I think the input would still be at most one, right? Not more than one, because you would input all of that string at once as one input string.
Correct. Well, so that would be item access, yes, but you could actually have a string, get string, and say you want to have them pass in 5 values or whatever, and then it's just going to say like, right? So,
Oh, like sequentially 5 strings.
yeah, exactly. So then it would
Got it.
be A, B, C, D, and E, and it would return a list of those values.
Right. Right.
So it's up to you. It's kind of whether you think the user would prefer to ask them 5 times or, you know,
Separated commas. Yeah.
one big string.
I'm not sure if that was answered already, but one question, like, is it maybe on your roadmap to sort of make it possible to develop a custom inputs? So I'm thinking about the situation, for example, you know, you could request input that will be specifically a closed poly surface or something very specific, because my definition will work on that type of data. So if the hops will be, or player will be accepting geometry that is very generic, I might get a lot of errors. So I guess it would be nice to first be able to create some sort of warning system, sort of like object is not instance, or something like that, or like your object is not closed, like please close it. Is that a part maybe of something that you were thinking about developing as well to give more flexibility to the users?
Yeah, what we've tried to do is suggest that if there's a parameter type that's not there, so like an image, for example, like get an image or something like that, is that you would pass in a string and then do something with that string. So for example, you can encode a string or encode an image as a base 64 string. The same can be true with geometry, and we'll show, I think, that when we get to hops, how it's passing geometry from Rhino to a web server as a string. So we're going to pass geometry or points or an image. All of this is getting formatted as a JSON string, essentially, that gets passed to the server. And so, you could have a component. In fact, Firefly, I don't have Firefly installed on this machine, but one of the new components that I've been working on is convert a Firefly image to base 64 and then convert it back, right? So base 64 is just an encoding scheme which takes the image and writes it into one big string. And so you could essentially have some component upstream that creates your string, you pass it in as your value, and then you sort of do something with that string, right? You'd have to then turn it back into an image, blur it, and then pass it back out as a string or something like that.
Yeah. Hey, Andy, I think there's a simpler answer to that question. Drop the geometry input in there. And if you right-click that, you can see that you can set it to accept only points or curves or surfaces or B-reps or meshes. And I think that's what the question was. Is that?
Yes,
is that right?
I mean I saw that.
Yeah.
So that's that's great. That's very useful. I was thinking more about even more specific elements. Like I need to have let's say an open
Oh, okay.
I need
yeah,
to
like
I need to be like
the
even
has
more
to be
specific.
has
Yeah,
to be
exactly.
closed.
Yeah, exactly.
Mm-hmm.
Or the curve actually need to be a polyline.
Yeah.
So
So
this is obviously super useful, but I was thinking about more specific cases.
Yeah. I guess you could like feed that into you could test to see whether it's closed and then prompt the user.
Yep.
If it's not.
So you could do a test like, is point inside boundary, right? And if it's not, you could use this context print, which would say point is not within boundary, which would bring up something to the user. this might,
I guess that would be a way. Mhm.
and you could even do that check and then stop the definition at that point, right? You could do like a stream filter, which says like, if it's this, then end, otherwise continue on. But yeah, you could essentially do your test and then provide some sort of feedback to the user, probably with this context print component, which essentially does that little modal that pops up. I'm trying to think. I mean, like I said, if there are other parameter input types that you think you might need or want, you can certainly let us know, either on Discourse or on Slack or email.
Mm-hmm.
That we're always open to new suggestions. Like someone actually requested the file and the Boolean, and so we put those in recently. And so we're definitely open to adding more as they feel like they're needed. But I also think you can kind of get away a lot with a string. So even with a string, you can pass in really, weather data or an image of something and do something with it. So you can kind of usually get away with some things by just converting it to a string and doing something with that string down the road. But yeah,
Andy, to that point, is there a way to like reorder the order in which the Grasshopper player prompts those messages?
Yes. So as I mentioned, it's actually the order from top to bottom on your Grasshopper.
I see.
That's great.
So if this is higher up, then this will get shown first, and then second and third. With hops, that is not yet taken care of. So that's on my to-do list to work with hops to basically do that same idea. Is that so you can kind of control the order of where the parameters go on the component will be the same, but right now hops does not have that feature. You just sort of have to accept wherever the parameters are with hops. But yeah, it should automatically, depending on your location of these on the canvas, is sort of how it chooses.
Nice. Thank you.
Yep.
Hey, got another question. Super interesting stuff. But is it possible to extend these context input components? Let's say that I wanted to add some, I mean, it was kind of talked about before, but like if I wanted to add some, very finicky specific input type, is there some sort of, I mean, the same way that you can create your own Grasshopper components that have certain interfaces and behavior, is there a way to sort of extend and create your own?
Probably. I mean, yes, I would think we would have to probably maybe expose some of the methods
right
that are there. We haven't necessarily made it user-friendly to create your own.
Yeah.
But maybe that's something we should look at. Another thing that's been suggested, which I think is something that could be really, really powerful, is if we were to be able to automate the, if I open up the trusses base one, to automate the creation of a Grasshopper player definition. So you wouldn't even have to like go in and do this. It would detect like sliders and go ahead and determine if it's a double value or an integer value, and then look at the source and essentially create getters for those components, so that you would essentially just save as Grasshopper player definition, not have to worry about dumping all this stuff in, and then it would show up the same way. I think that's still a sort of longer range project, not long range, but in the next couple months is I'm hoping to sort of be looking at that. And the same thing would be true maybe for clusters, like being able to run, well, in clusters, you could do some of these, but also running clusters on hops. So we'll talk about hops in a bit, but yeah, I think there's lots of opportunities to either open this up to be wider, so that maybe there's an easy way to create a sort of contextual Git component. The problem is that these Git components work. The reason why they're called context getters is because they work differently depending on if you're using it for the Grasshopper player or hops. So you kind of have to.
You would have to sort of tell the context input what to do in these different scenarios, I suppose.
Exactly. So it's a little bit more convoluted than just saying create a Boolean type, because it
makes sense.
It works a little bit differently whether you're calling it in the Grasshopper player versus hops or Rhino compute.
I think it would. I'm sorry if I'm breaking in.
No, it's okay.
I think it would be amazing if one could like right click on for example, a slider and say, make me a get object connected to this and attach it to where this one attached to, like, you know.
Yeah, that's a good idea too.
Then
Yeah,
it could be like in the middle.
I was thinking to automate an entire definition, or potentially look for, you know, if we had a group that you say like GH player or some sort of thing, that it would, if you set it to only do groups that are, you know, have some sort of tag, that it would automatically try to detect those and put getters for those components versus do the entire definition. But
Because
yeah.
I think it would be important to still be able to control, like if you have it too automated, it will just generate it for a lot of stuff, and maybe you have some things that are not. Yeah, you don't want to run them. So if you have like some kind of control, but you can still automate it, except specifically the connection part, which is very annoying if you have it connected to 5 billion different things.
I mean, honestly, that's a great idea, to just be able to right click and say create getter, create Git component, because then it would just essentially put it just on the outside and reconnect all the sources. So this would automate that whole process. But yeah, that's a great idea.
Hey Andy, can we daisy chain a bunch of functions so that the getter could appear later in the process? So say because right now everything is sort of front loaded, right? You have all your input kind of set up, and then it runs, and then it gives you a result. Can we do a bunch of getters, and then it runs, and then we ask for another set of input, and then it runs again?
Well, you automatically see a live display based on what you've selected. So you could, I think, maybe use a Boolean to try to do that. But the other idea is to break this into smaller functions, right? So you could, you know, have this be create surface. And then, so you would call Grasshopper Player, load the create surface function. And then that might be the input to the next function, which is like, you know, create the trusses. And so then you would have this function, and so you would call the second definition step 2, which would be, you know, select the surface, the number of trusses, whatever. So to me, it seems like it's more of a way, instead of having one giant definition, you sort of break it up into smaller definitions. And that's really how I think we would encourage you to work from a programming perspective, is usually you want to try to break those, compartmentalize those things down as small and isolated as you can in terms of functionality. So, you know, this one function is just doing this one thing instead of having one function that does 20 things. And so I think you could sort of do it either or. When it comes to hops, which we'll talk about in just a minute, yes, we can do that too. So you can actually compile this into a single function and then, you know, have it pass into this function and then pass into another nested function and so on and so forth. So I think you'll see that in a little bit as well when we talk about hops.
I had a question about the speed of execution. You know, you can write things in code and compile it as an RHP. You can write it as a, you know, Grasshopper definition. You know, you could do, you know, many different things to execute a function, as you're kind of explaining in this workshop. By doing things this method, is it slower to execute?
No, I mean, it's the same. This would be just like you were running it locally, right? So, because it's with the Grasshopper Player, it's relying on doing the same. It's just kind of running Grasshopper in the background, and it's just waiting for you to input. So yes, I guess it would be slower because, you know, the inputs are waiting for an input in the command line, but the actual execution is the same. When we talk about hops, it's really dependent on where you are doing the computation, because we're going to be talking about sending a request to a server, which again, if it's on a faster server, if it's on a server running on a computer that is, you know, a really strong, high performance machine, might be able to crank through the solver faster and then send it back. So you really could gain some performance there, as well as using the parallelization. So there are some options for using hops to be faster, potentially. But in terms of the Grasshopper Player, it's really about the same as what it would be if you were running. It's just that it's, you know, providing a different mode of presenting it to the user is really how the Grasshopper Player works. Does that help?
Yeah, no, totally. Yeah. So there's no difference in like execution time or anything like
Not
that.
really with the player. With hops, yes, there is some potential for with hops, but with the Grasshopper player, it should be about the same as if you were running it locally. All right, why don't we jump into the next section, which is looking at hops. So hops is a project that started by a couple other developers internally, Steve Baer, Luis Fraguada, and Will Pearson, as well as there might be some other people. Kike, I think, may have worked a little bit on it. But Hops works in tandem with Rhino.compute. And this is where I was saying that Rhino.compute has primarily been written as a Windows application, a server essentially, to run on a Windows machine. But Rhino.compute is a open source project. You can find out if we click this link. You can come here. You can pull down the code, the source code here, and there's an entire set of developer documentation if you want to build this locally or actually set up Rhino.compute on a production server. So we have lots of documentation, and we're trying to fill this out more as well. And so Hops and compute kind of work hand in hand. Let's see, here we are. So it's written, like I said, in C#. The actual Rhino.compute part is written in .NET, C#. But there are opportunities to create other types of servers, other instances of servers using Python or even JavaScript. It's built on some of these other frameworks like Owen and Nancy. Owen is a way to essentially host have an application host another application, if you will. So here we're using Rhino and Grasshopper to host a web server that's running locally. Nancy is sort of a middleware framework that handles HTTP routing. But essentially what all this means is it allows us to have a client, if you will, a front end. So this could be your local computer. It could even be a web page. It could be mobile, and allow you to send information or a request as a JSON API, a REST API call to another computer program. Again, this could either be running locally, it could be running remote in the cloud somewhere. And this server could be running a .NET version of this server. It could be JavaScript, or it could be Python so far. And that server will take this incoming information and try to do something with it, and then send the information back. So it's essentially a round trip REST call. And depending on the setup, it might cache the information, and so that can also speed up computation if it's already made the calculation before. You can spin up multiple child processes as well. So this is sort of the architecture diagram of how Rhino.compute communicates with other devices. So that's sort of the Rhino.compute side. And like I said, from a open source perspective and how you would set up some of these servers, there are libraries that allow you to set up a .NET or a JavaScript or a Python client library, which we'll talk about a little bit later. Hops is a individual component that you can download from the package manager, which essentially allows you to make these API calls to Rhino.compute. So hopefully that makes sense. So as I was mentioning, so we can take our Grasshopper instance, our Grasshopper definition, and make a request to a .NET server running somewhere. It could be local or somewhere else. and it does some sort of calculation and then sends the information back, which we then use in our definition. We could then continue on in our definition and maybe send a call to a Python server, which might be, running TensorFlow or some other library, which is only available in Python. It could do some additional calculation and then send the information back. And then again, we can take it and have it feed out to a Node.js server and then round trip it back. So hops, the name comes from this ability to hop around to different applications and sending these API calls to get information to and from. So when we talk about the settings for hops and compute, really, if you haven't really gone and looked into hops before, under the Grasshopper preferences, so if you go to File, Preferences, down at the bottom, you'll see this thing where we can define the solver settings. And up here on the right-hand side, you'll see a bunch of different places where we can define the settings of where we want to, or how we want hops to communicate with compute. So for example, you can, one of the biggest ones that will probably uncheck at the beginning is to uncheck this, this dialog, because by default, this is turned on. So what this means is that when we launch Grasshopper, it automatically starts up this server. That's what I was talking about. It sets up this program that's hosted within Grasshopper, and it's running in the background, but by default, it's hidden, so you don't really see it. So when you open Grasshopper, you just see the Grasshopper canvas. However, if we uncheck that toggle, when we launch Grasshopper, we'll see in our taskbar a console window. And this is really useful for debugging, right? So you may not want to do this all the time, but for today, for this workshop, we're going to just uncheck it so that we can see the request incoming and then the response going back out, right? So we'll just see what happens when we uncheck that. The other thing, if you haven't already done so, I would encourage you to launch the package manager and search for hops. Again, you just search for hops and you can download the latest and install it, and it should give you access to the latest and greatest version. This is the preferred method because you can always upgrade and modify when a new package comes out. We have hosted it at Food for Rhino as well, because in a couple earlier workshops we taught, people had an older version that didn't really allow the package manager. And so, because the package manager, I think, started after 7.4 or something like that. So anyway, but we would encourage you to use the package manager if at all possible, because that will just help keep everything straightforward. So when you connect with hops, you're going to see a new component under, I think it's under the params util as well, or it's definitely under the params category. And it has a little hops, a hops actual icon. But you'll notice something odd about it is that it has no inputs or outputs. If you're familiar with how the Grasshopper UI shows these jagged lines when it doesn't have an input or an output, it's kind of odd to see one have nothing on either side. But that's because by default, it doesn't really know what to do until you give it a path. And so probably the most important thing, you can either right click or you can double click on the component, and it will bring up this path, which allows you to set the definition. So just like we defined in Grasshopper, a definition that would allow us to control the Grasshopper player. The same thing is true with the Grasshopper with hops, is we have to load in a definition that's sort of specific for hops for it to then send out to that remote server. So this can be a Grasshopper definition on your computer. It might be a remote a definition like a URL on some sort of web page, or even some sort of endpoint, which we'll cover all three of those methods in a minute. But actually, what I mentioned here before, that definition that we pass in has to be set up a little bit. in order for hops to work as well as it can. So one is we have these same contextual getters as before. We'll talk a little bit about how these are a little bit different. They're the same components, but their behavior, as I mentioned, is a little bit different when we use them for hops. But again, we have the getters, we have the main part of the function, and then we have something a little bit new to define an output for hops. We have to give it a way. We haven't really figured out a great way to tell hops to say we want this parameter to be our output value of the hops component. And so the way we so far decided to do it was to create a group object where you give it a specific name, which is RH_out, and then whatever the name you want to give your output name. So it could be max, it could be my number value, or whatever you want to give it. But when you do that, so here we specify our path, and that's what it shows us our maximum. And now you can see that when we specify that value, it packages up that definition and sort of makes it into a compiled little component, right? So now we've got an individual component that has asked us to locate two numbers, num1 and num2. Again, it's taken the name from that component and used it as the input parameter for the hops component. And then the output is going to be this number that we've defined. It's used, whatever comes after that colon as the name for our hops component. So it's taken that definition and compiled it into one single component that has num1 and num2, and then outputs a max value, right? And when it does its solve, so what's happening behind the scenes is it's packaging up that definition and sending it to that server. It's sending it to that server and doing some sort of calculation and then sending the information back. So let's look at a quick demo back here. I'm going to open up, let's see, hops, find maximum. So here is that definition that I was just talking about. And again, we have a num here where we say num1 and num2. With the prompt, this time the prompt is going to be, instead of the prompt being like the prompt that shows up in the command line, this will be what's shown under the tooltip. So when, just like normal, when you hover over a parameter, right, we get a tooltip that says, second item for comparison. So we could even say, we might want to say first item to compare, right? And we'll say this one will be second item to compare. So we've got a Git component for our integer values. It's going to do something, and then we create a group, which all we're doing is setting the name. I right click on it, I set the name as RHOut, and then whatever I want my name to be. So I hit save, and now if I open a new document, one thing I wanted to mention is, and I've had Grasshopper open for a while, but if you want, if you haven't already done so, I would encourage you to go to File, Preferences, and just unclick that Hide Rhino.compute console window. You can also see that it's automatically trying to launch on startup. So it's going to launch Rhino.compute at startup. It's going to also try to, by default, hide the console window, but in this case, we want to turn it on. And when we do, you'll see down in the taskbar that we've got this, little, it says Rhino.compute, and it's a little program that's running, which is just listening for, it's a server, and all it's doing is listening for incoming data to do something, right? And so, you should see something like that in your taskbar if you haven't already. So I'm going to then go over here, and I might try to move this stuff around so that we can see stuff happening as we. So you'll notice under params util, if you've installed hops, you should see something that says hops component right here. And you can drag that onto the canvas and and you'll see that it has nothing here. Now, if I double click, it says set the definition, or if I right click, I can say set the path, right? So either way brings up the definition. And now what we're trying to do is I'm going to go and find the one that says find maximum hops. So that's the one we just opened and we're editing. So I hit OK, I do OK. And now you can see what happened is that behind the scenes, I started getting some information passing through, right? Because it tried to go ahead and make a solve because it had some default values. And so what it did was it took that definition, it created an input that's called num1. And if I hover over it, you can see it says my first item to compare. It also automatically gave it a default value because if we go back over here, we passed in an input value to the here that was set to 5. If I set this to 20, right, and then hit save, it should automatically update. And that might be a bug. Okay, it might be a bug. But what happens if we... Okay, so I recreated it and now it's set to 20, but it should automatically, like for the name, for instance. So I found that the actual parameter, that tooltip, so the prompt and the default value don't seem to update. So that's something we might put on our bug list. But the name, if I wanted to call these A and B, for example, instead of num1 and num2, if I call this A and B and hit save, now I go back, you can see it's automatically updated our component so that A and B are now renamed. So we've got this. The other thing I'll mention is it's got a component or an icon. Usually if I were to do something, let me see if I can pull up a different one. Well, usually it doesn't have one by default. It just shows this hops icon in the middle. To set an icon for your component, you can simply go to File, Document Properties. And you can set an icon here. You can select an icon, and I've put 2 in the workshop files. You can either use a PNG or an SVG. I would actually encourage you to use the SVG moving forward because right now it's not going to actually, and then you can hit save. So you can, this should update as well. Right now it's still pretty pixelated because we're still using sort of a PNG version of that SVG, but we will be moving forward with we are starting to support SVG. You can see this one's actually using SVG. So eventually, that's also on our to-do list, is that the icon that shows up here will be much better resolution if you use an SVG icon here. So you can actually compile this, you can create your own icon for your function, and then you can set your output, right? So again, this component, if we were to give it 2 numeric values, so let's just, create 2 values. And every time I make a connection here, you can see it's hitting the URL over there. It's sending that value over there and trying to determine which is higher. So you can see that it's doing it. Now, sometimes it's not going to update. And you're asking, well, why is it not updating? It's not hitting every time. Well, that's that cache. If you remember, I mentioned that in Rhino.compute, there is a cache, which means if it's already made a calculation where it solved this definition for when the 2 inputs are both 5 and 16, then it's going to look and see in the cache that it's already done that and spit back the answer as 16. And that should speed up things quite a bit, right? Especially with long calculations. So you could even animate sliders, for example, and let it just run through every permutation, and it would take a long time, but once it's filled out the cache, then every time you do a slider change, it will be sort of instantaneous. And so that's because you're saying it to cache in memory and cache on server, it's sort of by default checking to say, do those. Now, if you don't want those, in this case, I don't want these because I want to show you hitting the endpoint every time. Now, every time I make a change, you'll see the values changing because it's not storing anything in the cache anymore. It's only doing it when I store those two values. Does that make sense? Sorry, I'm used to teaching in person. It's been a little while since I've taught virtually, and so it's easier when I get to see everybody's face. So
I'm getting an error. Sorry, I didn't mean to. But mine is maybe simpler. Path appears valid, but something that is not hops related. Do you know why this could be happening to me?
Can you, what does the error say?
Path appears valid, but to something that is not hops related.
Huh. And it's the same definition that is this find map?
Yeah, I tried on the two, like the one that I created and the one that you had in your examples.
I don't know off the top of my head, unless you would. And I assume again you've done the package manager and are on the latest version of hops. It's maybe possible that and that you're using the latest version of Rhino, because that would have the latest version of Rhino.compute. Out of those, reinstalling those, or I don't know off the top of my head. I don't know that I've seen that particular error. So maybe we could look at it after the workshop or post something on Slack, and I'm happy to kind of help after the workshop.
Good. Yeah.
If that's okay. So again, going back to this hops component.
Can I ask a question about the caching?
Yes.
So what kind of data does it, save? Because right now you're working with numbers. What if my inputs are geometry? How does it cache that?
Yep, that's a good question. I don't actually know. Let's see. I don't know how it's stored. Well, I do know. So it's storing it as I believe it's storing the solution at whatever it's returning as a JSON string, right? So it's storing that JSON string that would be returned to hops in the cache. And you can also see under preferences, you can clear. So see, it's stored 63 items in cache, in my memory cache, because I had it chosen. So if you wanted to clear that, you could, but that's also not the server side one, that's the memory side one. But going back here, if I were to, for example, add a get geometry, and let's just say we wanted it to be a curve as an input, and I'm not really even going to do anything. I'm just going to say, curve. I'm not going to do anything with this curve. I'm just going to put it in the scene and hit save. Now I go back here, you can see I now have a curve input. If I create a curve, okay, and reference that one in and pass this in, you'll notice that there is a export input as JSON. So I'm going to just curve test, save this as JSON. So if I go to my workshop files and go to curve test and open this with Visual Studio Code, and then I think I have to say format document. So here is that curve, and this is the data that basically gets stored. You can see this is the type, the information. Now this is the input, this isn't the output, but essentially it's the same idea you can think of. And so you can see that it says data, and this is the curve, and it's actually just like I was talking about before, that base 64 encoding of the geometry. This data right here, this big long string, is the base 64 representation of the geometry. So it's not trying to simplify or do anything off with it's not trying to create a sort of simplified representation. This is the base 64 encoded version of the NURBS curve that I referenced in. So if you were returning a curve as part of your output, you could do that same thing, and this is what would get stored in the cache, right? So it's essentially writing this data into the cache, and then if it just goes and checks to see if it's already received that value, and if it has, it returns that. And so it's just trying to essentially speed up the calculation in some way.
Andy, sorry if I missed it, but right now Hops is calling Rhino.compute in some McNeel server, or is it using Rhino locally to solve the?
It's using this server. So it's actually spun up. So what happened when we launched Rhino Grasshopper at the very beginning is Grasshopper now by default has this solver input, or maybe this gets set up when you install Hops. I don't quite know, but it has this new thing with Hops and Rhino.compute. So now every time you start Grasshopper, it's actually starting the server in the background. Okay. So it's just starting this little process that's in the background that really doesn't do anything unless you send it some information. So it's just what's that?
And in terms of like licenses, is this the same Rhino license that I'm using?
Yep,
Okay.
exactly. Now, there are differences. There are different licenses when you set this up for production if you're running it on a remote machine. So you can actually buy a specific license for running it on a remote machine, and that using core hour billing and stuff like that. So there is documentation. I think I mentioned on the compute, wherever I was. Anyway, the compute page. By the way, I should bring up this as a reference. Under the Rhino developer docs, there is a Hops page, which really talks about all the different ways you can use Hops and the setup, as well as compute has its own developer guide documentation. God, get out of the way. So if I go over to guides and compute and this licensing and billing, this talks about how you would set up the core hour billing. So there are ways, and then if you still need more, we have guys, mostly Will Pearson, who's been sort of helping people set up core hour billing and setting up the servers to run on a local remote machine. But yes, when you are just running it locally, it's free. It's just like basically, it's using your regular license setup, and it is running essentially Rhino headless, meaning it's running a headless version of Rhino on that server. So that little console window, which we'll show in Python as well. We're going to set up a Python version of the server. But essentially, it's running a headless version of Rhino. You pass it in your definition, it does the solve, and then passes back the data that you need. And so when it runs, so this little server is its own little headless version of Rhino that gets spun up every time you start Grasshopper. And if you don't want to see it, like I said, you can just simply hide it, and you'll never know it's even there. And when you're running Hops, you won't even know it's there, right? It's doing something, but you won't know it's there. But if you want to see it hitting, the endpoints and seeing like what's happening, you have to uncheck that so that you can see what's happening when it sends the request.
Super. Thanks.
Yeah. So I covered, you can set an icon, you can set the default values, you can set the tooltip. The other thing I wanted to bring up is the at most. The at least is really not that big a deal. I mean, it's obviously not going to do anything if you don't give it anything. But at most is where I was saying that it's kind of important in Hops of whether or not it really only matters if you're setting it for 1 or more than 1, right? So you can either leave this unset like that, or you can give it 5 or whatever. But anything more than 1 will treat this as a list. So when you come back over here, it would expect that you're going to pass it in a list. If you have it at 1 and you pass it a list, right? So if at most is 1 and I pass it in a list of 10 values. So let's see, let me go back and edit this definition, get rid of this curve. And let's say I set this to be, so we've set both of these to be at 1, right? And I come back, so that would make it seem like it's item access, right? But typically when you are doing item access, what's going to happen is it's going to make 10 and then we pass it in a remote call. So let's create a series. And let's say we have 10 values that we're going to pass into B instead. So now what it's done was it actually called these endpoints 10 different times. right? Instead of making one value where it's comparing it, this list against, or this number against a list, because it was item access, it's doing the first number against this one, and then the second number and this one, and each one is its own separate call to the server. If we were to go back and change this to at most and unset it and then save, now it redoes it, and it's still going to give us our at most, but it's doing the entire thing one time. So it's only making one call to it. And I think this will become a little bit more clear when we actually run. This probably wasn't the best demo to explain that. But essentially, it's asking you to set whether it's going to be item access or list access, depending on what you set in the at most value. So hopefully that will become more clear as we work with it today. I wanted to, so let's see, talked about that, talked about the icon. So let's talk about setting up a Python server. So I already mentioned in the email that each of you hopefully received that there's a few other things that if you want, you can install, including Python 3.10, which came out recently, CMake, Flask is another thing, which is a middleware that we'll use. And then this repo that I already mentioned, which is the compute repo, you would want to clone that. And so the reason why you clone that is because that's going to show up here under McNeel, wherever you clone it. In this case, for me, it's right here. This is the same repo that if I go over to here, is this repo. So I just basically cloned this code. I pulled down basically this file structure onto my computer. And the reason being is that there's an example here under source. I think it's this ghops server pi, and then examples that we're going to cover. But before we jump into that, what we need to do is make sure we install the packages that are needed to run a Python server, and they're called ghops server, and then of course we're going to try to use Flask in this example. So the ghops server actually lives on this pypi.org. It's basically the latest version of the Python server. So just like I just showed you, there's this server that runs in the background when Grasshopper runs up. Well, we have a Python version of that, which you can install and run locally. But all you have to do is run this command that says pip install ghops server. So if you haven't already done this, you can open up a version of PowerShell. So you just go to your command line or your start menu and type PowerShell. And then you're just going to type pip install ghops_server and then space and Flask. And then you hit enter. Now I've already done that, but if you haven't already done that, it should go through a download process that says, okay, I'm installing this. The other interesting thing is that the ghops server also installs some other things that are required, like Rhino 3DM. Rhino 3DM is the open source library that we use for like headless geometry in the server. So it's installing this other dependency as well as Flask and Rhino 3DM and some other things. So it's trying to install all of those things. Like I said, if you don't have CMake, you might run into an error. At least I had an error when I was running pip install on this new machine. So I would encourage you to just make sure you've got all of the prerequisites, and then open up PowerShell and run this one installation. Then once you do, you're going to go over to Visual Studio Code, okay? And you're going to go to File, Open Folder, and you're going to navigate to wherever you clone that repo, right? So we went to compute and then source and this ghops server pi and examples, and I'm going to select that folder, and all that does is opens that folder and I can see all of the files in here. So there's a few different examples that are already here that allow you to run a Python server we're really going to look at this one called app.py, mainly because it runs the Flask middleware already. But if we just open this example file, what we're going to see at the very top, again, feel free to stop me if this is going a little bit too fast, but what we're going to see at the top are a couple import statements. One is import the GOP server, and it's going to use the variable HS as the name. So it's going to import, if we've already installed the GHOP server stuff, it's going to import this, and then essentially right here, it's going to create a new instance of that Flask server or the GHOP server. So that's really where this behind the scenes is actually creating that server that we just talked about over here that's running behind the scenes. That all gets created essentially right here in this one line on line 9. We also have an import statement that has Rhino 3DM, and that's what I mentioned, that other library that essentially allows us to have, IntelliSense down here. So it knows that a curve, like most of the time, Visual Studio Code or Python isn't going to know what a curve is. But because we've imported that Rhino 3DM, we can say curve dot dimension, right, dot, or let's see, maybe we want to do curve domain dot T0. That's the interval of the domain, the first number value of the domain of that curve. So essentially it's providing access to Rhino's syntax, right? The syntax that if you are a developer and have used Rhino at all, you have probably used some of this, which is like how you might construct a function here that uses Rhino functions in any number of ways, and there's lots of examples that you can find online about how we can code in Python and or even .NET. But in this case, so we've imported the Rhino 3DM, we've imported the server, we've started the server and started Flask, and then we come up with these we come up with these definitions. I'm going to scroll down a little bit and just look at this one that's right here. So lines 42 to 55. It basically has this @ symbol and it says hops.component, and then it has a parentheses and it has a whole bunch of stuff inside the parentheses. And that's essentially going to define how the data is going to be coming in and going back out to this component. And so essentially the first thing that we see is that it's going to have this let's see, what do we call this? As a endpoint. This endpoint is called point at. So we can name this whatever we want. We could say curve point at or whatever, but essentially this particular function is going to take in a curve and a value along that curve. So if it was 0.5 and the curve was normalized, then it should be the middle of that curve. So it's essentially going to take a value, the curve and a value, and return a point, right? So, it's basically the evaluate curve component. And so what we're doing is telling Python that we want to create an endpoint called point at. And the name is called point at. It will have this nickname. We can give it a description and even an icon. In this case, this icon is already in this folder, pointat.png. Now, yours might, I think I made one change. Yours might say example.pointat, and I think that's actually an error in the code because we're already in the examples folder. So you actually just need it to be pointat.png because it's going to find that pointat.png file right there. You can see it right there. So the icon is there. The inputs that this component's going to be coming in is a curve. So hops knows that it's this hops curve and a hops number, and this is a number instead of an integer. And the output is going to be a point, right? So we have this as our, what the hops component is going to do. And then, so when we create this Python server and make this call, it's going to create a component that has these names and inputs and outputs. And then this definition in here is basically what happens when we call that point at function. So we're going to pass in this curve and a value and return the curve point at. Now this could be a much more complicated function. This could be, you know, a really long list of functions. It could even be using other libraries, right? It doesn't have to be just using, this is where I was saying, where it becomes kind of interesting. You could be using TensorFlow or some other thing. So you're importing TensorFlow or NumPy or some other library that you particularly like that does some sort of calculation and is used in this and returns some value. But this is a really simple example where it's going to take in a curve and a value and then return that point. So what we need to do now is we've defined this app.py, right? So we need to tell Python, so if you don't have a terminal up, you can say terminal, new terminal, or go down here in Visual Studio Code and go to terminal. So right now we are already inside, because we've opened this folder and we are clicked on this app.py, we are inside this examples folder. That's where the terminal is sort of locating this. So if you've installed Python correctly and Flask and everything else, you should just be able to type Python, and then we want to run the app.py. And when we do, you'll see that it's giving us a little warning that says it's a development server, it's not production ready, we have this, and then down here it's saying running on, and it gives us a URL. So if you're not familiar, localhost or your computer, the default IP address for that computer is always 127.0.0.1. And then it's already assigned a port 5000. That's just the port that was just set up in the Hops server. When we created this Hops server right here, it was set up as a default port 5000. So right now we have this little server running at localhost 5000. So what we can do is go back over to our definition. So I can go to File, New, and I'm going to pull this up a little bit so you can still see the terminal running in the background, right down here. So I'm going to create a new component, and this time instead of passing it in a path to a file on my computer, I'm going to pass it a IP address, this IP address. So instead of doing that, I'm going to take this value and just copy. And then over here, I'm going to type in this. And then at the end, I'm going to type in that point at, right? Because that's where it's saying go to that particular endpoint and look for how to construct this hops component, right? So we have defined that this component, when we give it this endpoint, it's going to have a name called point at, a nickname, a description. It's going to have an icon and everything like that. So when we type in this server address, this port number, and then an endpoint, it goes to that endpoint and tries to construct the component. And now you can see it's actually gone and created a component that has a C input, which is the curve to evaluate. So here you can see curve to evaluate is defined right here as an input. The T parameter is the parameter on the curve to evaluate. So again, here, the T, we have that, and parameter on curve. The icon is set because it knew to go and look for this point at PNG, which is in that example folder. So if I go to sources, ghops server example point at, and open this, and it's really hard to see on that background. Let's go to, there you can see is my icon, right? There's that icon right there. So this, when we told Hops to go to this URL, it knew to go to on my computer on port 5000 and look for this definition of how to construct the component. And then the solve part of it, like what it's supposed to actually do, is to return the point at on this curve. So if I go back over to Grasshopper now, and let's just use that curve. Let me just move this over here. So if I were to select a curve and say set one curve and select it, now you can see, because it's got a default value for the T, which is 0, that it actually did something, right? It came over here and said solving using legacy API point at, so it hit this point at endpoint, and then did a post. And so if we give it a value here, if I pass this in, you can see it did another, it tried to call it again. So again, now we're instead of calling the local server over here, right? We're not calling this server. This hops component is communicating with this other Python server. Now you may be asking, like, why is my point not really moving? Well, it is moving, but my curve is not normalized, right? My curve right now is not normalized, but I can still do the same types of things I would do normally, which is I can reparameterize my input. And now, if I go 0 to 1, my point is anywhere along that curve. And you can see the same. You can see Visual Studio Code showing those endpoints being hit every time I make move this slider down the way. So far, so good. So another thing I wanted to cover is how we can start to daisy chain. This was a question that was brought up a minute ago, is can we start to daisy chain these things together? And the answer is yes. So I can open up this, I think it's this Voronoi cells definition. And this is a Voronoi cell definition, which is asking for a curve and a point. And all it's doing essentially is creating some random points around here and outputting a Voronoi pattern. So it's not all that interesting, right? So we have this Voronoi, and then it's outputting the cell. So this is the same thing we just did earlier with that find maximum. We've done the naming as RHOut cells. And we've got curve and point, and both of these are set at most 1 and at most unset. And I'll show you why on that in a minute. So I'm back over here. If I were to create another hops component, only this time I'm going to point it instead of to my Python server, but this time I'm going to use the Voronoi cells that I just showed you and hit OK. So now this component is communicating with our .NET server, right? The one that starts up when Rhino starts up, or when Grasshopper starts up. So we've got our Python server running here, our .NET server running right here, and a single definition, which is sort of communicating with both of those. So here I can pass in this curve and our point, and now it's created the cells. And so again, if I move that point around those curves, you can see it's actually doing both of those. It's still communicating with both servers, right? So it's calling the Python server and returning the point, which is then feeding it into this definition, which is communicating with the other server and returning some geometry. Does this make sense? So this is a really, I think, simple, hopefully, but also interesting way to start to communicate with these different programs. And again, these don't have to be running locally. They are in this instance. This is running on my computer, as is this. But these could be running in the cloud somewhere, right? This could be running in the cloud, and all you're doing is sending these HTTP requests to communicate. And so I mentioned earlier that the reason why I want to set this to a list is because if I were to create this as a range, for example, and pass it in a list of values, and then give this a number of, say, 30. If I were not to do this, right, if this were expecting a single value, it's going to take each one of these values and return a point, and then that point is going to get fed upstream. So if I go back to, let's see, it's actually this point. So this is returning a single list of values. But if I were to set my Voronoi cells to at most to be just 1, right? Now for every point it gets, it's going to solve another solution. So it's going to look different, right? So this is where I was getting, is that, like, basically you're duplicating that call, because essentially it's trying to create 31 different calls and returning 31 different groups of cells of 11. Hopefully that makes sense. But if I go back and say, I just want this to take in the entire list and only make a single call and hit save, Now when I go back and recompute, now it's basically taking in a single list and only doing it one time, and then returning just a single list of 41 polylines. So that's where I was mentioning is that depending on how you set your at most value, you can really determine, you can have a difference in how the calls are made to the different servers.
Super cool. This is really cool.
Thanks.
So I can set up like a WSL. I can set up something in Windows Subsystem Linux, a Python Flask server in Linux basically, and then I can sort of communicate that to that server, right? I can have that server compute this.
Linux, the Rhino 3DM part is only compiled for Windows. The Rhino compute is only compiled for Windows. So you can have a server, a Linux server that is doing some sort of thing and then makes a call to another server that's running Windows with Rhino compute.
Got it.
And then passes back to your Linux server and then whatever. But no, for Rhino compute, you pretty much have to have it on a Windows machine. But yes, I mean, so theoretically, again, depending on your configuration, you could have a Linux server, but it's not going to be the one running the Rhino compute instance, if that makes sense.
Got it.
But
actually, I had a question about that as well. So I'm curious about this Python server. Is it actually running the Rhino compute server in the background? How does that work?
Yes. So when we set this line here, it started a server. And so when we call app.py, it starts going through this function and it hits this thing and starts to create the server. So if I go up in the code, you'll actually see, let me end it and restart it. So when I start it, you can see it says running on, and that just basically means that the server, so it's saying serving Flask app, and so it has essentially created that server in the background, or this is the server that is running, and again, this is all set up in that GHOP server. So this is basically this information right here. So if you went up a folder in Visual Studio, again, this is all open source. So it's in that Rhino compute repo. So if you want to know what's happening in the GHOP server, you can actually go in there and look at what's happening and how that server is being started. But in the example, it's basically just starting up the server and starting up Flask and then helping route the endpoints to the right position. Hopefully that makes sense.
Yeah, that makes sense. Yeah, thanks.
And so this, I think, opens up some really interesting possibilities because, again, you could be hosting these files. One thing I forgot to show is you can host not only the server, but Hops can also take a file remotely. So your file doesn't even have to live on your computer. For example, there is a example that is on, so here's the Rhino compute. If I go to source, hops, definitions, there's a couple of definitions here that are just Grasshopper files. There's really nothing special about this particular Grasshopper file. But I'll look at this particular example. If I go to a new definition and pull hops down, one thing is I need to be able to pull in the raw file. This is a blob right here that's being shown. So I actually need the raw version of this. So if I right click on download, I can say copy link address. And if I use that here in this hop, so you can see it's actually going here. So there you can see it changed raw from blob to raw. But it's a URL address. It's not on my computer. I can click OK. And this automatically knew to have an icon, and it's still using my server, my local server. So here, it's using this server to do the calculation, but it's pulled the definition remotely. So I can, now feed this values, whatever I want it to be, and it will do the calculation, and you can see it's actually hitting that server when I make changes. So another way you can start to think about how to distribute things is to maybe store definitions for your company on a certain remote server or a remote computer that everybody can then just connect to at home. And so there's sort of a single truth as opposed to having everybody have definitions, you know, somewhere else or something like that. You can actually begin to save definitions remotely and just call to them when needed. So there's also ways I think that are kind of interesting of how we start to store and share information, as well as being able to control what endpoints and what servers we're actually communicating with. Does that all make sense? The last other thing I wanted to mention about the daisy chaining and recursion, so we call that recursion over here, this Python example with the Voronoi, this one. So here we're kind of 2 levels deep, and there's sort of one communicating with a Python server and one communicating with the local server. But there is an example I wanted to show where I think another interesting thing to think about is recursion that normally would be kind of difficult unless you use maybe the Anemone plugin. So if I go to this divide curve component, this has a line input and sort of an amplitude. So if I show you what that looks like, what this component does, I'm going to put a line component on the canvas or in Rhino and pass that in. And then the amplitude is just some sort of value. Let me give it. Is just going to take the midpoint and sort of move it up, right? So all I've done is created a, it's really dumb, right? It's just a line. I divide the line and I take the midpoint and I move it up normal to that line. So it's got to be normal to that line. And that's all I'm doing in this definition. So it's got 2 getters and then we have our output. So if I open the other one, that is divide curve hops recursion, what you'll see, let me hide this and go to the top view, is I've now sort of daisy chained these hops components together to create a recursive, this is actually the same idea as a Cook snowflake recursion. So what's happening here is I start with, let me do this, is I start with a star, right? That's all this is this particular curve input is a star. And I'm essentially shattering it so that each of these segments is its own line. And then I pass that line into the component. And you can see what it did was it took this line segment and moved the midpoint up. It took this line segment and moved its midpoint up, and so forth. So then I take those line segments and pass those to another hops component. It's the same one, but this time and I'm dividing the distance by 3. So each time the distance gets a little bit smaller. But so I'm taking the line that I just subdivided, or that got subdivided, and doing it again, right? So each time it's recursively doing it more and more, and you can just keep that pattern going, right? So you could copy these 2 components and do one more level of recursion. So I just pass this, and I think I need to flatten this input. Hopefully I didn't just crash it. There we go. And so now I'm one more level deep in terms of our recursion level. So I've taken each of those line segments and I've subdivided it and subdivided it and subdivided it and subdivided it. So normally you would either have to write a script to do this or use a custom plugin. But now you're essentially making that same function and calling hops to call it and then do it again and again. Now I should mention that there is a limit to the recursion level. So there's only, we've set a default of 10 recursion limits. So that could be for this, that same Python example or here, but there's only so many nested computations that can be used before we sort of say you can't do it anymore. But I think this is also a kind of interesting demonstration of using hops in a recursive way to create some fractal pattern that would normally be difficult to do in Grasshopper. But now we can take just standard Grasshopper components and do it in a unique way. Are there any questions about any of the stuff so far? Why don't we, I mean, so now's a good time to sort of take a breath and maybe answer any questions about hops in general, because the very last section I wanted to cover is the script compiler, and that won't take too long, but it's sort of, this would be a good time to sort of break for a second and answer any questions about hops.
I guess for starters, the CMake doesn't seem to be working, even though it's been added to the path variable.
Let's see. You should just be able to, so when you did pip install, are you getting a CMake error? Do you know?
Yes, I am, sorry.
Okay, so I think what you have to do is run this installer. You may have to close PowerShell, and you may even, I don't know if you're gonna have to update, like restart your computer. I maybe should have mentioned that. But you'll probably want to pull this MSI down for CMake and run it, and then maybe restart your computer. And then when you run pip install ghop server, hopefully that error message will go away and it will automatically run through. Because I had the same issue that you're running up against earlier when I was trying to do it. And essentially, if you haven't, I didn't have it on a different machine, but that was because I already had CMake installed. And so I'm glad I set up a new machine recently, which basically caught the same problem you're running into, which is that the pip install requires CMake to essentially compile the code, the Python code server.
It's probably restarting, so I'll try that maybe at the end of the session.
Okay, yeah.
My CMake says C compiler not set, and C++ CMake _ C++ compiler not set. Is that just like a parameter that I need to set, or is it asking for C compile or C++ compiler that I need to have on my computer?
I think so, but I don't know. I'd have to look individually. Maybe, again, maybe we could put create a Slack question. Are you on the Slack channel for the AECtech this workshop?
Not yet. I'll join shortly.
Okay. There's a Slack group that is for this NYC McNeel compute. And I think if anybody's running into questions, it'd be great to post them here. And if I can't seem to find out the answer, I'll certainly try my best to find someone internally who can. Now, I'll be the first to admit I'm not a Python expert. I tend to do most of my coding in .NET, but I know enough to kind of get around in it. But I'm sure I can either find out an answer or hopefully help answer the question. But I think for the CMake question, hopefully restarting. I don't think you need G++ or GCC installed. I had to install those recently for a different development project, but I thought CMake would have installed what was needed for the, so I'm interested to know if you do need another dependency that I just happened to miss. So if we do need to set a compiler and another dependency, like there are other ones called GCC and G++, like this one, the GCC new compiler. But I didn't think you needed that in order to run the pip install. So I am curious to see if that's something that we do need to install first. So if you run into that error, certainly let me know. Again, it's only necessary if you want to run the Python server code. If you want to just run hops locally and use the .NET server, that should start automatically out of the box. So it's really only needed, the pip install and the Python server stuff is really only if you want to run that Python server and then potentially use, other Python libraries that are out there like TensorFlow. But if you're just trying to use hops out of the box, my recommendation would be just to use, the one that runs when you launch Grasshopper.
Andy, one question. Sometimes like you start in Grasshopper with one input, let's say a curve, and then you are running two sort of parallel processes. Like one is creating a surface out of that curve, and then from the same curve, we are creating points. And then at the end, you bring those two together. Right. But I understand that Grasshopper would run that actually linearly, like as one single process. If we use hops as is like two kind of hops, would that run parallel? I mean, faster, or is it the?
So there's a couple things. One is depending on, so you can see it is trying to run in parallel. The behavior is that it is trying to run in parallel. The other thing is you can do this asynchronous, which means it will wait. You can turn on this asynchronous call. It means that this will wait until this returns with its value, but it also won't lock up your Rhino Grasshopper. That was the other thing I was mentioning, is that essentially if you turn asynchronous on, it will, if this is a really long running calculation, it's not going to lock up Rhino and Grasshopper like it would if you were trying to run a single definition, right? So if you had a really big definition and you hit go or compute, and sometimes you just have to sit there and wait and not do anything for 10 seconds, that won't happen when you turn this asynchronous call on. So you can turn certain calls to be asynchronous if there are certain long running ones to wait to go to the next stage.
So could you use that for like in combination for with like Galapagos or something such? A lot of mess.
I haven't tried it, but I mean, again, it should work because unless I'm mistaken, I haven't. I think it should work because the plugin should work on the head. If you've got the plugin installed on your machine and you're running it locally, Galapagos should run headless in that version. So theoretically, each call to Galapagos, I guess it depends on how Galapagos does the threading and if it's returning a value after each solution. I know that by default it doesn't. You have to open up a separate modal and run. I know there are other genetic algorithm libraries or plugins that might do it differently, in which case maybe those would be worth pursuing. But I don't know. I mean, I guess the reason why I say I don't know is because I just haven't tried it. Theoretically, plugins will work, right? So you can use any kind of plugin as part of the hops because it's going to install the plugins when it starts. So theoretically, I don't see that being a problem. I guess it's just a question of whether it's doing the return call and how you set up the asynchronous part.
Cool.
Andy, do you, so previously the question was asked about if you had specific plugins, would it work on hops or not? And so it's related to that, but if you put your descriptions on your company server, not your desktop, if you had specific plugins on that server, then that would run all of your scripts through hops.
Right. So the plugins need to be installed on whatever machine that server is running. So if you're running, I don't know, Human or UI or MetaHopper, I don't know, whatever, and you have configured your server to run remotely, then those plugins also need to be on a remote machine. And so we're not going to necessarily try to start installing plugins on other machines. So that's sort of left up to the user who's configuring that server to know that they would need that plugin installed. If it is installed, then yes, it should work. It should load the plugin when the server loads up. If that makes sense. I can restart. Does anybody have any questions about any of these things? I guess I can redo any of them. If I restart, you'll see the plugin, and you can see it shuts down. So if I restart Rhino 7 and then launch Grasshopper, we're going to see our console window. There it is. And you should be able to see loading Grasshopper. Let's see if it does it. Okay, well, this loading compute plugins. When you run this in debug mode, which again, if you don't have the source code and aren't compiling it from code, you don't really see it. But when you're running this in debug mode and you're compiling from source, you actually see all the plugins that get loaded. And so you can see this if you're installing a third-party plugin, you'll see those loading. But essentially, it does load plugins. So when you make that call, it should, if it's on this computer, it should load it.
Thank you.
Is there, could you maybe talk a little bit about the level of ongoing development for the Hops Flask server? It looks like maybe the GitHub hasn't been updated in a bit. And there's a couple params that seem like they're maybe not enabled yet. Are there plans to keep kind of pushing that forward, or is it?
I think it is something we want to keep pushing forward. I think if there's specific questions, we'd love to know what you would like to improve. I think we kind of put it up there as a just a sort of getting started example of like, here's how you get Hops and Flask running as a Python server. Mm-hmm. But we haven't really gone more because, it becomes kind of domain specific depending on how you want to set it up. If there are wants and needs, we are, we kind of rely on our users to tell us, what isn't working or what they need more help with. So obviously, if there's more information that you'd like us to add or more parameters or anything like that, I think we'd love to do it. I think Ehsan and Steve set up the GHOP server. Actually, if I go to the PyPy page, yeah. So I think they're the maintainers. This is Ehsan. He taught the workshop this morning. And Steve there. They're the ones who sort of set up the GHOP server and have sort of been maintaining that. And so I know if there's interest or questions that they'd probably be the best to ask, but obviously I can help direct that or even help add more stuff to that repo if it's useful. Cool. So I think, like I said, I think they just took it to a specific point to get it get someone up to speed with setting it up, but I don't think they wanted to take it so far to where like it's super specific. I think they really just wanted to do enough to where it shows you how to add a component, how to do stuff, and how to set up certain types of input parameters. It's also open source, so if there's other things you want to add, we can do a pull request, and you're welcome to sort of make some changes and make a pull request, and we can review. And so we're obviously open to suggestions and even making it better.
Cool.
What else? Anybody else? All right, I wanted to show one last thing because I think we've covered a lot of stuff today. But one thing I think is kind of cool is this one thing. I'm going to go back to that sort of example, that silly example at the beginning, which was just find the maximum. Right, so we've got this example. It's nothing special, but let's say you had this, and let's say this was some amazing script that had some inputs and did something. It could be that twisty tower thing. It could be any number of things. But let's say we wanted to create this into a package that was its own standalone plugin that you could send to someone or even post up to the package manager, right? So, we have this package manager and we install Hops or Amoeba or whatever you want. What if you wanted to create, you had your own definition that was really useful that you wanted to distribute either as a plugin on the package manager or just you could email to someone and they could drag and drop and then run it. So one way to do that is to go to under tools and go to the script compiler. And the script compiler is this, it opens this little application. And you can see by default, it's pretty bare bones, to be honest. But it says at the default, it's going to help create this Rhino script compiler, these RHC files, into RHP files, which are the Rhino plugins files. And you can create your own ones by VB or Python, but it can also be these Grasshopper definitions, which I think is pretty interesting. So what we're going to do is start a new project. So I hit N. And again, this is going to be the project name. It can kind of be whatever you want. But in this case, I'm going to say like, we'll call this find max utilities. And so it's now opened up this file. It says, where do you want to create this RHC file? Now I would recommend that wherever you save this RHC file has to be in the same folder as where your Grasshopper definition that you're referencing. I found that as a bug, that if you don't say, and so again, this is another thing we need to add to our to-do list, but if you don't save this RHC file in the same place as this, as wherever your Grasshopper definition is that you're going to use, then you'll get an error. So make sure you save this RHC file wherever the Grasshopper definition is. Okay, so once we've done that, now you have essentially saved that RHC file. So if I go back to here, I've created, here's that RHC file that I just created. Now, there's not much in it right now. I need to actually, I can edit the author settings. So you can see there, it doesn't have an author. It doesn't have any information about the commands or anything else. So I need to edit the author by hitting A. So I'll type in N for name, and it asks me to enter the author's name. So I'll type my name. I can set the email, which is andy.payne@mcneel.com. If you want to set the website or phone or country, you can do all of that stuff. When you're done, you just hit enter. So now you can see the author information has been filled out, right? Or at least some of it. Now the next thing, I can go down the list and say, set the plugin settings. So I can hit P. And so the name, if I wanted to change the name of it, I could do that here. You can set the version number, description. I can hit D and say, these are a set of numeric utility functions. You can choose where you want the output. I'll just set that to bin. That's fine. You can set a URL or platform if you want it to only be Windows or Mac OS. The minimum Rhino version. These are all things, but you can use the default. The next thing is the command. Now the command is kind of interesting because the command is going to say what are the definitions that you want to use as part of your commands. So in this case, I'm going to only do one, but let's say it's this find maximum that I just showed here. So we've got this find maximum here, and I'm going to hit open. And so now it has a name called find maximum. It's a type command, it's a Grasshopper file, and it's located the file. Now, if I wanted to edit that, I could hit 1. And I could change the name to find max to numbers or something. I don't know. You can kind of do whatever you want. The interesting thing is this is going to be the command that you type in as a command in the command line, right? So if you wanted to, you might want to make it somewhat useful. So think of this as basically trying to compile a Grasshopper Player function, and this is going to make a new function in Grasshopper that you can run to find the two numbers or whatever. But once you're done, you can hit enter, and I'm just going to actually edit that back to say find max num name find max num. Okay. You can also add multiple commands, right? So this doesn't have to just be a single RHP, single Grasshopper file. You could have, your entire library of functions that you've created. could be stored here. And so you can have any number of functions that create here. I'll hit enter. So now I've got to find the commands. You can see find max number. Again, you might want to save the project now that you've set some of these things. So I'll just save max utilities. That's fine. And the next step is to build the current project. So we're going to hit B. And if everything works, it is going to go through and compile your definition into and your RHC file into an RHP, a Rhino plugin, and build a Yak command, a Yak manifest. So here's my RHC file. It created a bin folder. And now I have this RHP file and this Yak file. So if you're not familiar, Yak is sort of the way you can upload or distribute RHP files in the package manager. So you might want to Google, I'm not going to go through that, but if you do Rhino Yak distribute, I don't know. Let's see. So you can come here and go to the package manager fundamentals or here, and essentially it tells you how a Yak is created. You have your RHP file, you've got a YAML, things like that. But this is sort of the bare bone. This tells you how to upload things on Yak. And so here, what we've now created is that Yak file as well as the RHP file. So if I go back over to Rhino now, and I drag and drop my RHP, so this you could email to a friend or whoever or distribute in your company, and we drag and drop that onto the canvas, it says it's now loaded the find max utilities RHP. So now if I type in find max number, it's a number. And it's going to run through and basically call the Grasshopper definition, just like we had it before, as the Grasshopper Player. So I can set the first integer to 10, the second one to 20, and it's going to return the result. So just like before, we can create, and so you can go back and edit any of this stuff too. So once you can open an existing RHC file, edit any of this stuff, and then rebuild it and create a new plugin. And so you can begin to edit and create your own libraries of functions that you've created either for the Grasshopper Player and or Hops, and have it run as its own plugin. And then you can even distribute it on Yak or the plugin manager so that people can say package manager and download my awesome plugin or whatever you decided to call it, and it would be there and people could start to download your own work. So I thought that was kind of also a good way to kind of begin to finalize and show ways to distribute and share the work that you're doing with other people and get some collaboration, or just distribute it and let them play with the stuff that you're working on. Are there any follow-up questions? I know we've got about 10 to 15 minutes left or so. Are there any questions that I haven't answered so far?
Yeah, hi, Andy, just a quick one. Basically, these compiled version of the script, will it run Grasshopper in the background as well? Or it will be kind of native compiled?
Yes, I believe it's basically doing the same thing as if you were calling the Grasshopper Player, right? So here, Grasshopper Player. To be honest, I haven't tested this if you've embedded hops in here. What would happen? I think it would still work, honestly, because it would spin up the server as well, because it's going to load Rhino and Grasshopper in the background, a headless version, and spin this up. So I think you could still distribute even if it was a hops component. If it was, as long as it was calling to that endpoint, right? This one, if you've got a Python server or something, you've got to know that it's calling to that specific endpoint. Yes, I think it's basically doing the same thing in the background. So it's either calling like the Grasshopper Player, like we talked about, or if you have a hops component in there, it would be communicating with some sort of server. So both should work. I haven't actually tested the hops component as the RHC or the RHP, excuse me, but I believe it should work, embedding even a hops component within the plugin.
How about like if we have a script that has a human UI interface already?
Again, if it doesn't have on your machine the plugin, it's going to pop up just the same way if you sent this definition that had a human thing and you sent it to me and I didn't have human UI plugin, it will come up and say, Grasshopper says it's detected some plugin that it doesn't have. It will then try to go in and find it on the package manager, but it's kind of up to that owner to know if it's on the package manager or not. If it is on the package manager, it will show an easy way to download it on your computer and sort of get going. However, if it's not, you're going to have to kind of go somewhere and do it. So even if it's running Grasshopper Player, if you have a definition that has a plugin that isn't on that person's machine, you'll still see a warning come up that says, I don't have this plugin. Do you want to install it, kind of thing. So that should still, again, that's sort of why that we're trying to push people towards the package manager as a way to publish their plugins, because it is so useful for sharing with other people. It gives them an easy way to just pull down that plugin. So yeah, they will get a notice, they'll get a modal that'll pop up that say, we didn't find this on your machine. Now, if they can't find that definition and the package manager doesn't have it, then your end user might not be able to do anything. But
got it. Cool. Thanks.
Yep. Anybody else? No?
Really awesome work. Just being able to see kind of Rhino.compute kind of opens up computing in Rhino, like so that we're not kind of stuck with Grasshopper. We can like branch out to so many other possibilities. It's really exciting.
Yeah, and if you're familiar with web development, basically what we're doing is web development. It's a web server that's running. It happens to be running a headless version of Rhino in that web version. So, you're sending the same REST API calls that you would to a server. It just has to be formatted in a certain way. But, I think people who are familiar with web development or setting servers up in that side, this should come pretty natural, I hope, to some people. We also want to make it as easy as possible. We haven't nailed everything. Obviously, I think there's things that we could make better. The RH out in a group to define the output is not all that elegant yet. And we used to have, that's how we used to define inputs, was it would be RHN, but then we created those context getters. And so components. So maybe we'll figure out a better way for outputs, but for now, that's what we have. But I think we're always open to suggestion. I thought the suggestion to be able to right click on a slider or input toggle and be able to add a getter on the output could be really useful. And so, I might bring that back to the team and see if they agree. But any and all feedback is obviously valued. And so if you guys have feedback either on Slack or on Discourse, please feel free to jump online or email, and we'll do our best to either find an answer or improve the software.
Here's a question. Clusters seem to kind of be set up in a similar way to the hops definition. Would it be possible to export a cluster as a definition that already has the hops formatting in it? I know that's not developed yet, but
that's on our list for sure. That's where I was going to go, where I was saying that we would like to for the GH player, be able to automate the process of basically automating, irregular definitions. You don't have to sit there and add all these getters. The same thing, I think, for clusters, you just nailed it, is that clusters are so similar in a way of like compiling something and
Mhm.
running it. Now we can actually run it and make a call to a remote instance.
Yeah.
And so I think it makes total sense to have clusters basically turn into hops components or
Mhm.
a version of that. And so that's also on our wish list or feature list that we're working on towards, but it's not there yet.
Cool.
But certainly I think in the coming months, you'll hopefully see some development towards that.
That's great.
Okay, well, I'm happy to stay on for a few more minutes if anybody has any more questions. If not, I appreciate everybody taking the time. I hope everybody learned a little bit today. And like I said, feel free to ping me on Slack or email. And thanks again.
That's
Thanks,
really
Andy.
great, Andy. Thank you very much.
Thank you.
Yeah, absolutely.
Thanks,
Thank you
Andy.
very much. This was amazing. Okay.
Yeah, absolutely. Thanks again for coming.
That's fantastic. Thank you so much.
I have one silly question.
Okay.
Before we go, how was it that you got the console to pop up?
If you
I had to step away for a moment and missed that.
That's okay.
And I found the Grasshopper settings and unchecked the hide Rhino.compute console.
Oh, then if it didn't show up, so if you, yeah, so you may just need to restart Rhino. It should automatically.
Okay, I've done that too.
And it's still not, this is unchecked?
Yeah, it's unchecked.
And you're not seeing anything in the taskbar?
No.
And
Oh, no, I'm wrong. I totally missed it. It was down in the taskbar.
yeah,
Minimized.
kind of
Okay.
We
There
ought
it
to
is.
actually add an icon too so that it shows up.
Yeah.
Yeah, cool. Glad that's working.
That's great. Very cool. Well, thank you very much.
You're welcome. Thanks for coming.
Yeah.
I have probably a silly question, but is ops making the definitions lower? Because I was kind of, I don't know, searching online for the difference between like ops components and clusters, and it seems that many people are like longer computation period when they use ops.
That's a good question. So I don't think it, well, it could be potentially longer. If you're running it locally on a server, it's not going to be any faster, right? Because it's the same computer processor that's running the definition. And it depends on how you're making the calls, if you're making 10 calls versus one call. Plus you're adding in the time to have it Grasshopper send them that big string, right? It's got to package up the JSON request, send it to the server has to process it and send it back. So you're adding on to that send and receive time as well, which usually is not very much, but it's a little bit, right? So it's adding that little bit on top of whatever the normal time would be. Where you could see benefit, I think, is by doing parallel operations, because you can make parallel calls. You can run it asynchronously. So if you do have a long thing, you can actually tell it to wait, and that way not lock up your definition or lock up your UI thread. And then lastly is you have the option with Hops to put it on a machine that's running a much stronger processor, right? So if you configure it to run on a remote machine and make the call to a remote machine, then it should be faster, right? Now you still are bound by that limitation of sending and receiving, right? So if we have a supercomputer, but it's in Russia and I'm in America, and the time for me to send my URL request to Russia and back is, 100 milliseconds or whatever it is, then you're adding on still a little bit of time to that calculation, right? So I'm not saying that it's slower. It shouldn't be any slower than running it locally, except for, like I said, there's a little additional bits. But it kind of depends on your configuration. You might get faster if you're sending it to a stronger computer, or depending on if you're running it in parallel and things like that. But we haven't done a lot of benchmarking, so to speak, in terms of how much performance you might get.
Okay, because it's super exciting, and I was thinking, you know, to clean up my definition with a lot of these components instead of having a lot of clusters. But I'm very curious to try out if it's gonna be like any slower.
I don't think it will be. It shouldn't be any significantly slower. Like I said, you're still basically the only thing you're adding on are the request times. The rest is still running on your same machine, so it's essentially running the same as it would run normally. So it shouldn't take significantly longer. You're just adding those little bits of time it's got to take to go back and forth.
Okay, amazing. Thank you very much. It's everything's super exciting, like
Great.
very, very inspiring. Thank you.
All right, thank you.
I'm gonna make a last silly suggestion for the instead of the grouping thing.
Okay.
Why don't you make like Galapagos, like that kind of icon that you have like the dotted connection to. So you just have and say this is the output dotted line, and have a tap, like a beer tap.
Say that one more time. I don't know that I quite understand. You're saying
If you have a Galapagos component in your script, you don't connect it with normal line. You connect it with the dotted line to say this is my data you should run on. You know what I mean?
Yes, I do know. So you're saying basically
have hops two components. One is the hops component, and then the friend. Like this is the thing.
Right. I think I would agree that I don't know. So I just started at McNeel not too long ago, and I somewhat agree and somewhat disagree with the way this has sort of taken shape. In that, I think it's interesting that these context components can do multiple things, but I also kind of find it confusing that like some things are not really used in hops, like, but they are used in the Grasshopper Player and vice versa. And I almost wonder if it would be better if we had just Grasshopper Player inputs and hops inputs. But in which case I could see having a hops output that's specific for hops output.
Because it would make it so clear in the script that this is the hops part. Okay, this is what I'm looking for.
Yes.
And as a dyslexic, I want the least text as possible to not get angry.
Part of the problem, I could see it with the output. Part of the problem is, I guess you would just have to take the component name, the output. The input does have a lot more settings. Like you kind of set default, you need to know the list access and stuff like that. So for input, I think the Git components could do it. I could see something like a hops output thing that you're saying, where you just sort of drag it and do something like that. And you're just sort of pointing at things that you want it to be as a hops output. So I could see it more as a hops output feature. But again, it's a good suggestion, and I'll bring it up to the team and see what their thoughts are.
Cool, thank you.
You're welcome.
Great work today.
All right, great, thanks. Anybody else? All right. If nobody else has any questions, I think I'm going to sign off. Thank you, guys. Appreciate it.
Thanks, Andy.
Thanks. Bye. Thank you very much.
All right, bye.
Bye-bye.